which is inverses of matrices and matrix equations. Okay, so first of all, the first concept is that of the identity matrix. It's the n by n matrix for which each main diagonal entry is a 1, and for which all other entries are 0. So, for example, I2, it's a 2 by 2 matrix, would look like this. So the main diagonal is this right here. Goes from the top left down to the bottom right. And all the entries are 1s, and all the other entries are 0s. I3, which would be a 3 by 3 matrix, would look like this. Okay, so again, the main diagonal has all 1s, and everything else is 0s. Okay, so that's pretty much what those are. Now, usually we say I, not I sub n. Okay, we call this identity matrix I, and this identity matrix I, not I3, not I2. This is only just to kind of introduce the topic, saying that there's lots of different identity matrices. It just depends on the size. Now, it has to be a square matrix. Square means it's n by n, the same number of rows as columns. Now, here's an important property of the identity and why it's so important. It acts kind of like 1 in multiplication. So, you know, if you take like 5 times 1, that's 1. You know, any number times 1 is just that number. I'm sorry, 5 times 1 is 5. So any number times 1 is just that number. So the identity matrix acts the same way. Let me come down to number 1 first. We won't come back to this other stuff. The identity matrix acts in that same way. That's why it's important. Okay, so hold on a second. Okay, let's do number 1. So the matrix I equals, so we're down here, 1, 0, 0, 1 is called an identity matrix, which should be the answer. Matrix. Okay. If A is a 2 by 2 matrix, then A times I is equal to A, and if I times A is also equal to A. If A and B are 2 by 2 matrices with A, B equals I, then B is the inverse. Okay, so that's how the inverse works. It's some other matrix so that if you multiply it A times B, you get the identity. Now, let's come back up to here. Let A be an n by n matrix. If there exists an n by n matrix A inverse with the property that A times inverse is I sub n and A inverse times A is I sub n, then we say A inverse is the inverse of A. Okay, so that's how it's written like that. So here, we're just buying a matrix B. And so here you'd say B is actually equal to the inverse of A matrix A, is A inverse. Okay, now, if you have a 2 by 2 matrix, then you can just find the inverse this way. So if the entries are A, B, C, and D, then you take 1 over AD minus B, so A times D minus B times C. And you multiply each by this matrix here. You just rearrange things so the this entry goes up to here, and this entry here in the top left goes to the bottom right, and then these two are just made negatives, and then you multiply everything by this in the end, and then that'll be the inverse matrix. Okay, that's for 2 by 2 matrices. This is for 2 by 2. For larger matrices, then you can find the inverse. Oh, by the way, and if AD is 0 and minus BC is 0, then A has no inverse. Okay, so for larger matrices, you can find the inverse by doing row operations. If you put the matrix in and you augment it with the identity matrix to the right of it, and you make one big matrix using matrix A and the identity, and you do row operations to where this becomes identity, then what you have over here will be the inverse. Will be A inverse. Now, if you can't get the identity here, then that means that A does not have an inverse. Okay, when you do the row operations. Okay, so let's go on to doing more exciting homework exercises. Okay, now, why are inverse matrices important? Well, there's a lot of reasons. We're just going to give one reason that's based on systems of equations. Okay, so here we have a system, and we're supposed to convert it to a matrix equation. So what you do is you do the coefficients here. I'm just taking the coefficients of these right here, and then I'm going to put an x and a y there, and then over here it's the right-hand side of the equation. So these ones go over here. Okay, now we talked about this last time about how to set this up, but the idea is that if you take this matrix, so you can ignore all these arrows, by the way, just ignore them for now. That's only so you can like make the matrix bigger and smaller. Okay, so if you take this matrix and multiply that out matrix, you get a 2. This is a 2 by 2. This is a 2 by 1. So it's 5 times x plus 3 times y. 5x plus 3y. You get that for the one entry, and then the other entry is this one. And then you're setting it equal to this. You're basically setting basically it's the equivalent of this system here. Okay, now the inverse of A is okay. This is A right here, 5, 3, 5, 3, 3, 2. Okay, so we'll come over here. So A is equal to 5, 3, 3, 2. Okay, so if we compare these two, compare that with this, then little a is 5, little b is 3, little c is 3, and little d is 2. Okay, so first thing you want to do is calculate AD minus BC, which will be 5 times 2, 10, minus 3 times 3, 9. That's 1. Okay, so that's really nice. It's just 1. So the inverse is going to be 1 over 1 times, so that's this part here. This is just 1. So D, negative B, negative C, A. But we know that D is 2, so that's a 2 there. B is 3, so that's negative 3. C is 3, so that's negative 3 also. And then A is 5, so that's going to be 5. Okay. And so because we have just a 1 right here, then that doesn't have to distribute in. It's just, and this would be the inverse right here. 2, negative 3, negative 3, 5. Okay, so it goes there. Okay, now let's focus on this part right here. So this is AX equals B. Now I'm gonna write it with a little space in front here. What's gonna happen is we're gonna take this A inverse matrix and multiply it on the left. Okay? And when you do that, this part here just becomes the identity times x. Okay, so that's telling you that, and then identity times anything is just that whatever that is. So this is just I times x is just x. I'm just really botched that. That's telling you that x would be A inverse times B. So that's what this equation is right here. X is equal to A inverse times B. So we put the entries in. the A inverse entries, 2, -3, -3, 5, and then the B entries, which are 1, 1. And then we calculate this. So 2 times 1 is 2. -3 times 1 is -3. Add those together, you get -1. 1 times -3 is -3, plus 1 times plus 5 times 1, that's 2. So -3 plus 5 is 2. So then the solution is -1, 2. Okay, so we kind of did this in a completely different way, but it makes sense because of this chain right here. Now, if the inverse matrix doesn't exist, then it's one of those cases where you either have infinitely many solutions or no solution. Okay, so when the matrix inverse exists, when A inverse exists, then you're going to have a unique solution, just one. It's the case where you have only one solution. And I guess the nice thing about this one, I guess it's not really teaching you how to do anything that you didn't know how to do already, because you could have just done this the traditional way and solved the system. We could have solved this another way. Probably elimination would be the first line of thinking, rather than going through and finding the inverse and multiplying this all out. But I suppose that if you wanted to do a whole bunch of solve a whole bunch of systems where you're just changing, where everything, well, this remains the same thing, and you're just changing that, then this might be more efficient. Okay, so let's do number 3. Okay, so number 3, calculate the products A, B, and BA to verify that B is the inverse of A. Okay, so AB will be, okay, so I'll go 1, we have to copy this down, I guess. Oh, that's a 2. And then B is right, this one right here. Okay, now let's go ahead and multiply them together. Now for this plot right here, again, it's the first column multiplied by, I'm sorry, the first row here multiplied by the first column here. So 8 times 1, or 1 times 8 is 8, plus 3 times -2, that's -6. So 8 minus 6 is 2, plus -1 times 1, that's -1. So that's going to be a 1, not a 0, 1. Okay, so 8 minus 6 minus 1 is 1. Okay, and then for this one right here, for this entry, it's going to be this row and the second column. This is the first row, second column. So that's going to be 1 times -3, that's -3, plus 3 times 1, that's 3. So -3 plus 3 is 0, and then -1 plus 0 is 0. So that's going to be 0. Okay, and then just continue on there. So this one would be this one times this row. So 4, and then this is -3, and then this is -1, so that's also 0. And then here, this entry here would be this row. So 1 times 8, that's 8, minus 8 plus 0, that's 0. And then the middle one, 1 times -3, that's -3, plus 4 times 1 plus 0, so that's 1, and so on. So if you continue on, let's see, this one right here is also going to be 4 minus 4 plus 0, that's going to be 0. This one's going to be going here again, -8 plus 6 plus 2, that's 0. And here it's going to be this times this, that's going to be 3. Minus 3, that's going to be 0. And then this last one is going to be negative 4 plus 3 plus 2, that's 1. And so that does it. So that's how you would check that. And then you can go back the other way. You're still going to get the identity the other way. Okay. Well, we're not going to do that, but similarly, b times a is equals to identity. So identity is 1's on the main diagonal, 0 everywhere else. And so, yes, they are inverses of each other. Okay, number 4 is simply find the inverse of this matrix. So again, we're going to calculate AD minus BC. So again, here A is 1, B is 4, C is 1, and D is 3. That will be 1 times 3 minus 4 times 1. So that's 3 minus 4, that's negative 1. Okay, now the fact that that's not 0 means that it will have an inverse. So, okay, now I'll put the entries in. So the D is 3, and then the A is 1. So 3 and 1 go there, and then this becomes negative 4, and this becomes negative 1. But then this is negative 1 right here. So you distribute that negative 1 in, and you're going to get negative 3, 4, 1, and negative 1. Okay, number 5, find the inverse of this matrix. So here, we first calculate AD minus BC. That would be 9 times 3 minus a negative 9 times negative 3. So that's this times this minus that times that. And this is 27, that's also 27, and it's minus 27, so that's going to be 0. So that means that the inverse does not exist. So just put D and E in any cell of the matrix, and it should mark it correctly. Okay, so number 6, find the inverse of this matrix. So here we have a larger matrix, and the way that we're going to do the larger matrix is doing this. Okay. So let me just walk you through this one. So you form a large matrix where you just copy this one down. And then you continue this out. You can put some dotted lines here if you want to keep a boundary. And you write the identity matrix right by it, or the entries to the identity matrix. Okay, so that's what this means. You have this matrix A right here, and then you have the identity matrix augmented onto it. Okay, and we're going to do our operations to where this looks like the identity. So the first thing is to try to get a 1 up in this corner here. And let's see here. What I'm going to do is I'm going to add 1 times this row to that one. So when I do that, so 3 minus 2 is going to be 1. Okay, so if I add these two together, I get a 1 right there. Okay, so that means that the top row stays the same. And this row becomes 1. See, that times that is negative 2, plus 3 is 1, and then 1 times 7 is 7, plus 7 is 14. 1 times -2 is -2 plus 0 is -2. 1 times 0 is 0 plus 0 is 0. 1 times 1 is 1 plus 0 is 1. And then 1 times 0 is 0 plus 1 is 1. That stays there. Okay, so you can see that as we're going along, this matrix changes from the identity. And eventually, when I get to the point where this is the identity, then this will be the inverse. Let's continue. This time I'm going to swap these two rows. Okay, so I'm going to use that operation. So the top row will be 1, 14, -2, 0, 1, 1. Middle row stays the same. Bottom row becomes the top. The top row goes to the bottom. I think I probably should try to keep these lined up really carefully like I'm doing. Okay, now I'm going to multiply 2 or this by the top row and add to the second row, and I'm going to apply -8 to the top row and then add to the bottom row. Okay, and that's going to give me, the top row stays the same. -2 times 1 is 2 plus -2 is 0. 2 times 14 is 28 plus 7 is 35. 2 times -2 is -4 minus 2 is -6. 2 times 0 is 0 plus 0 is 0. That stays a 0. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 plus 0 is 2. Okay, now -8. -8 times 1 is -8 plus 8 is 0. That zeroes that out. -8 times 14. Oh dear. That's -112. Plus 1 would be -111. Ouch. Okay, -8 times -2 is 16. Plus 3 is 19. And -8 times 0 is 0. Plus 1 is 1. So that stays the same. And then -8 times 1 is -8 plus 8 plus 0 is -8. And then -8 times 1 is -8 plus 0 is also -8. Okay, oh dear, what do we do here? Okay, so here's what we're going to do. We're going to multiply this row by 3 and add it to the bottom row. No, yeah, 3. 3 works. I'm going to try to get a 1 right here. That's the next objective. But we only can use these 2 rows to do it, not use the top row to do it. Okay. Okay, so 3 times 35 is 105. Plus, minus 111 would be negative 6. Okay. Then 3 times negative 6 is negative 18, plus 19 is 1. And 3 times 2 is 6, minus 8 is negative 2. Okay, now I'm going to multiply this bottom row by 6 and add to the top, to the middle row. Okay, this kind of looks like I'm going in circles, but you'll see what's happening here soon. I'm just trying to do this to show you. Now, usually what would happen is you would end up with fractions, but in this particular case, so a lot of times it's unavoidable, but in this particular case, it can be avoided. Okay, so now when I multiply by 6 and add here, okay, that's still going to be 0. 6 times negative 6 is negative 36, plus 35 is negative 1. Okay, so now I have a negative 1 there, which means I can just multiply this by negative 1 and get a positive 1 there. Okay, 6 times 1 is 6, plus 6 is 0. That's great. I like the zeros. 6 times 1 is 6, plus 0 is 6. 6 times 1 is 6, plus 3 is 9. And 6 times negative 2 is negative 12, plus 2 is negative 10. Okay, and now I'm just going to multiply this by negative 1. And now it's going to give me, and let me do 2 things while I'm at it, okay? Just because I want to save space. So I multiply this by negative 1, and that's going to give me, it's going to make all these negative, like that. And then while I'm at it, I'm going to multiply this by negative 6 and add to there. Okay. Those are 2 steps. If I do them both together, then it's the same as if I did one and then I did the other. And I did something similar. I can multiply this by 6 and add to the bottom row. I can multiply that one by 6 and add to the bottom row. Or I can multiply this by negative 6 and add to the bottom. It's the same thing. Okay, so negative 6 times negative 1 is positive 6 plus 6 is 0, so that's 0. And then negative 6 times 0 is 0, plus 1 is 1. Whoa, I have a 1 already. Wow. That was nice. Negative 6 times 6 is negative 36, plus 1 is negative 35. And then negative 6 times 9 is negative 54, plus 1 is negative 53. And negative 6 times negative 10 is positive 60, minus 2 is 58. Well, this is crazy. Okay, now I've got the identity except this and this. I have to get rid of that and that. So you get rid of this one by using this row, multiplying that by negative 14 and out of the top. Because we don't have very much time left, I'm going to go ahead and I'm just going to skip to what it would be, okay? So basically it's going to add negative 14 there, and then I'm going to add 2 times that one to the top as well. Okay, and so I'll get a bunch of stuff. In the end, here's what's going to happen. As you can see, these 2 rows are not going to change. And this row is going to become 14, 21, and negative 23. So that means that the inverse matrix will be this right here. Okay, so that would be the answer to that part, to that question there. Okay, now I got to show you how to do this using Geogebra because that's going to make your life a lot easier. So let's take number 7, and we'll do the thing on that. Okay, so here's number 7. Find the inverse of that one, and then we're going to do this way using Geogebra. Okay, so the matrix 0, 1, 0, 1, 1, 0, 0, 0, that's 1. Okay, so I'm going to put that into Geogebra. Okay, so here I've opened that up, and since we're not really using the graphing part, I'm just gonna like push that screen all the way over to there, okay, because we're not gonna be using the graph. Okay, so this first matrix, I'm going to put it in. So you just put it in as a matrix, so it's curly bracket, and then the first row, 0, 1, 0, 1. That's the first row, comma, and then you do another curly bracket for the next one. And then the third row, and then the fourth row. And hit enter. And so you can verify that that is actually the matrix from the homework exercise, and it is. And then you just type in A and then put the super, like the shift 6, which is the caret thing, put a -1 there, and hit enter. And it says undefined. So that means that that the inverse doesn't exist. Okay, so you just come back over here, and the answer to that one is simply does not exist. Okay, so if we had done this method, then we would have probably happened pretty quickly. That we would have figured out that there's no way we could there's no way we could get this right here, identity there. Okay, so a more complicated matrix. Let me show you how you would do that one. And so let's go ahead and put that other matrix in, that matrix in. So I'll go back over to our good friend Geogebra, and I'm going to call this matrix B, and the entries are I need to put the entries in here. Okay, double check that that's the right one. Okay, so now when you do that, you get this. Okay, so you get this matrix here, and you're like, whoa. It's not going to accept these decimals. It's not going to accept these decimals in the answer. So what you have to do is, what you can do is this. If you look at the numbers in the matrix, you've got a 6 here. You got -5 there. Maybe that's not even done it. What you have to try to do is figure out what the fraction form is going to be. Okay. So it looks like maybe if we multiply everything by 6, that might be helpful. So 6 times B inverse. Still not, doesn't quite get us there. Let's try 12. Oh wait, you know what? I made a mistake in inputting the inverse. I made a mistake here. This entry should be -1 or -6. So you would get this one, and then if you multiply by 6, you get that. And you multiply by 12, you get that. Can't believe I made it. So if you made, so I guess the most important thing is to get this input right. Now this is unacceptable as an answer, but if you multiply by 12, you get this one. This is all integers now. And nothing you can factor out of here. There's no integer that you can factor out of this. So what you have to do is divide every single entry in here by 12. So this will be 11 over 12. 12 divided by 12 will put a 1. So it'd be 11 12ths, 1, 1 12th, negative 1 12th, negative 1, negative 1, 0, 0, negative 17 over 12, negative 1, 5 12ths, 7 12ths, so on. Okay, so you have to input it like that, So let's go back over to this one. So here we're going from 12 times A inverse, or we used B inverse. We used B for here. So this is what I said, just what I said the entry should be. Oops. Okay, so if you can't figure out, so there will be, when you do these matrices, there will be a number that you can multiply the matrix by that will make it all integers. So make all the entries integers. Okay, and we'll talk about, next time we'll talk about what that number is. It's called the determinant. Okay. So here, number 9, we have A is this matrix, B is that matrix. You're supposed to find this, B inverse AB. So again, we can just use Geogebra to do that. I'm just going to go ahead and delete all this. Okay, and I'm going to make A this new matrix. And then make B the other matrix. Okay, and then double check that those are the right ones. I don't want to make a mistake like last time. And they wanted B inverse AB. So B to the inverse, oops, AB. Boo. Okay, it looks like you have to do the same kind of thing. Looks like repeating 3s is indication of a 3. A 0.5 is indication of a 1/2. So 3 and 2 are 6. So we're going to multiply by 6. And okay, so we just take this and divide by 6. Divide all the entries here by 6. So this should be a negative 11/6. This is 3/6, which is negative 1/2. This is 2/6, which is 1/3, and so on. Okay, or you can, if you can't figure out what integer to use, you could always just do it the other way by hand. But it would take, this way it's generally going to save you a lot of time. if you have a calculator, then that's also, then I can also do that, and so the operation can be performed this time. Okay, number 10. Finally, we pull it back around to the original one. We're supposed to solve the system equation by converting to a matrix equation using the inverse of the coefficient matrix. And so, this system can be rewritten this way. And so, this is matrix A, this is X, and this is matrix B. So, again, the idea is this right here, is that you multiply on the left by A inverse on the left. So you have, these are all both on the left. And then these cancel out because that's just identity. And so you get this. So the objective is just to calculate that. Now, what we can do is just put all these matrices into Geogebra. So here's A, there's B. Or we could just do it by hand, I guess. Maybe that would be easier. Okay, so then A inverse B would be right there. Okay, now right here you're getting these decimals again, but this is a whole bunch of nines, just indicates round off error. So this should be 378, and this should be negative 150. So 378 negative 150 would be the answer. Okay, so that would be the answer to that one. And then do the same thing here. Convert that into a system. So XY, so we got X, Y, Z, W. So W is the last one. I know it's out of alphabetical order, but Z comes before W. But in the alphabet, it's the other way around, but that's weird. Okay, so this one here is going to be 1. There's no Z, so that's a 0. And then there's negative 3 for the W. And then here it's 1. There's no Y. So it's that way. And then this one, there's no X, so that's 0, 5, negative 1, 1. And then this last one's 4, 4, 0, negative 2. And then X, Y, Z, W equals the right hand side, which is 0, 2, 6, 10. Okay, so I'm going to make that A and make that B, and the answer will be A inverse B. Okay. So let me delete these. And then you calculate A inverse B. Yay, that's nice. 2101. That's the answer. From our good friends at Geogebra.